Bismillahirrahmanirrahim. In today's lecture, we are solving problem 4.1 from Applied Thermodynamics by McConkey. So problem is 1 kilogram of steam at 20 bar. So पहले हम first we write given data. So in given data m is equal to 1 kilogram of steam. Working fluid is steam at 20 bar. P1 is equal to 20 bar. Dryness fraction x is equal to 0.9 is heated reversibly at constant pressure. It means that process is reversible isobaric. Isobaric means constant pressure process. Constant pressure process. To a temperature of after reversible isobaric process, temperature means T2 is equal to 300 degrees centigrade. Calculate the heat supplied and the change of entropy. Change of entropy means S2 minus S1. And show the process on a TS diagram. It means that draw TS diagram. And shade in the area which represent the heat flow. So these are the required things. Required means Q, to find Q, change in entropy, and draw TS diagram and shade the TS diagram. So we start solution. TS curve, first we draw the TS curve, temperature and degree centigrade and entropy kilojoule per kilogram per Kelvin. The curve TS curve is like this, and this is the constant pressure process. So this is liquid region and TS diagram. This is liquid region, this is wet region, and this is superheated region. This line is called saturated liquid line and this line is called saturated vapor line. So pressure is constant in 20 bar. So constant pressure process on TS diagram is such like this. And in wet region constant pressure line is straight line. In superheated region constant pressure line is like this. And over this line pressure is constant and is equal to 20 bar in this problem. Pressure is equal to 20 bar. Initially dryness fraction is given to us. Dryness fraction is x is equal to 0.9 and the value of x is 0 on saturated liquid line. The value of x is 0 on saturated liquid line and x is equal to 1 on saturated vapor line. It means that in wet region the value of 0 is from 0 to 1 and we are given that the x is 0.9. It means that first point will be here, x is equal to 0.1 and point 2 we can find point 2 from temperature T2 is equal to 300 degrees centigrade. First we find saturated temperature in this region. From this point to this point temperature is constant. So and this temperature is called saturated temperature. First we find saturated temperature from saturated steam table. So from saturated steam table at pressure is equal to 20 bar. If we check saturation temperature at this pressure, this is equal to 12.4 degrees centigrade and we are given the temperature is 300, more than this value. So from this point to this point temperature is 212.4 degrees centigrade, but we but the temperature given to us at point 2 is 300, more than 212.4. It means that the second point is in superheated region. Superheated region is temperature given to us T2 is greater than saturation temperature. So the property of the steam at 300 degrees centigrade are in superheated region. It means that point 2 will be in superheated region. So this is point 1 and this is point 2. So this area is the one point shade in the area which represent the heat flow. This area I shade this region. This region is the heat supplied. Area under the curve, this is point 1, this is point 2. Area under the curve on the TS diagram is called heat supplied. So this is point 1, this is point 2. This is total curve from point 1, from process 1 to 2. So area under this curve is called heat supplied. So this is TS diagram and this area represent heat supplied. This area represent heat supply. Now this is TS diagram and this is curve, and we will find heat supplied is equal to H2 minus H1. Similarly we will find change in entropy H2 minus S1. So for this we are finding first H1 and S1 and then we will find H2 and S2. So H1 and S1 are in wet region. H1 and S1 are at wet region, and H2 and S2 are in superheated region. So we will find H1 and S1 from wet region from saturated steam table, and S2 H2 from superheated steam table. As we know that H1 is in wet region, and formula for H1 is H1 is equal to HF plus X Hg minus Hf, and S1 is equal to Sf plus X Sg minus Sf, and Hf, Hg, Sf, Sg are given in saturated steam table. So from saturated steam table, from saturated steam table, at pressure is equal to 20 bar, Hf is equal to 909 kilojoule per kg, and Hg is equal to 2799 kilojoule per kg, and Sf is equal to 2.447 kilojoule per kilogram per Kelvin, and Sg is equal to 6.340 kilojoule per kilogram per Kelvin. Now we are found H1. H1 is Hf plus X Hg minus Hf, and S1 is equal to Sf plus X Sg minus Sf. Putting values in these equations, so H1 is equal to 909 kilojoule per kg plus 0.9, and Hg is 2799 kilojoule per kg minus 909 kilojoule per kg. Similarly, S1 is equal to Sf is 2.447 kilojoule per kilogram per Kelvin plus the value of X dryness fraction is 0.9, and Sg is equal to 6.340 kilojoule per kilogram per Kelvin minus Hf is SF is 2.447 kilojoule per kilogram per Kelvin. So H1 is equal to 909 kilojoule per kilogram, and simplify this value, 2799 minus 909 and multiply by 0.9. So the answer will be 1701 kilojoule per kg. Similarly, for S1, which is equal to 2.447 kilojoule per kilogram per Kelvin, plus simplify this value, 6.340 minus 2.447 and multiply by 0.9. So the answer will be 3.5037 kilojoule per kilogram per Kelvin. So final value of H1 will be equal to 2610 kilojoule per kg, and S1 is equal to the value of S1 is equal to 5.9507 kilojoule per kilogram per Kelvin. Now we are finding S1, H2 and S2, and H2 and S2 are in superheated region. So now from superheated steam table at pressure is equal to 20 bar and temperature is equal to 300 degrees centigrade. Pressure is constant, so pressure at point 1 is 20 bar and point 2 will be with also 20 bar, and temperature T2 is 300 degrees centigrade. So at pressure 20 bar and temperature 30 degrees centigrade from superheated steam table, H2 is equal to 3025 kilojoule per kg and H2 is equal to 6.6768 kilojoule per kilogram per Kelvin. Now heat supplied Q is equal to H2 minus H1, which is equal to 3025 kilojoule per kg minus H1. H1 is 2610 kilojoule per kg. So Q is equal to 415 kilojoule per kg. This is heat supplied. Now change in entropy, S2 minus S1 is equal to, S2 is equal to 6.768 kilojoule per kilogram per Kelvin minus 5.9507 kilojoule per kilogram per Kelvin. So S2 minus S1 is equal to 0.8173 kilojoule per kilogram. This is change in entropy, and entropy is increase. This is increase in entropy. And problem 4.1 is completed. And for more video, please like and subscribe my YouTube channel. Thank you.